Hello and welcome back. Today's video is on Kant. Right, ready for this? Okay. In case you haven't heard of Kant, his work, especially the Critique of Pure Reason, which was published in the 1780s, is considered a watershed in the history of philosophy. So, for example, we've already seen how Copernicus's work in the Copernican Revolution had these huge ramifications on the philosophy and physics and everything. And Kant's work, the Critique of Pure Reason in particular, is considered to have another huge watershed ramification on, say, philosophy, and a lot of scientists took it seriously too. I think in the past I've made some comments about how mathematicians and scientists didn't really need to pay attention to philosophers anymore. Well, they did pay attention to this one. So in order to understand the videos that come after this, we really need to understand parts of Kant's teaching. And in this video, I am only going to touch on the stuff relevant to this video series and our concerns here. I'm probably not even covering the most important stuff. Like if you just wanted to see a video on what was Kant, the very first stuff they'd probably launch into and said, you need to understand this stuff, is probably things that I'm not even going to cover in this video. I'm just talking about what we need to know. I am narrowing it down to just what we need. And hopefully I can be successful on that. So before we go into his philosophy, let's fill out the sort of historical context. He was a professor in the town of Königsberg, which was in the Kingdom of Prussia, which was currently led by Frederick the Great. He was in the late 18th century, so it's the late 1700s. He was a professor there. I've said several times in this series already that he was probably the first big name contributor to this narrative after the humanist revolution. After the innovations of science and learning were moved out of the university system. So now it's actually sort of moving back to the university system again. So what could have caused that? Well, at the time in the air, it was the Enlightenment, and the idea of sort of free inquiry as a virtue was in the air. Frederick the Great was definitely a person who bought into that and allowed the universities in his kingdom free inquiry within certain limits, of course, not absolutely free, but definitely free inquiry compared to what we were seeing back at the time when the sort of scholarly types were demanding that the Pope condemn Galileo. So in this loosening of restrictions and allowing people to just guess, ask questions, develop things themselves, came the opportunity for very smart people to finally flourish and start contributing as university professors in the university system. And that's the sort of context in which he rose in. This is after the Protestant Reformation, which was religious reformation, but was also a big political one. A lot of princes aligned themselves with the Protestants and sort of throwing off the authority of the Catholic Church at the time. So the church didn't necessarily have authority in Prussia anymore. And Frederick the Great was allowed to say, yeah, universities can have freedom of inquiry, freedom of thought within some limits. I don't think they could actually criticize Frederick the Great himself, but if they wanted to contradict Aristotle, what did he care? So that was allowed. All right, so let's see. At this time, science was going great guns, lots of developments, and a good number of philosophers may have had some science envy. It could have been perceived that maybe philosophy's kind of been spinning its wheels for thousands of years. It's difficult to talk about what traction it may have got or progress it might have made, but at the time, it definitely seemed that science was making lots of progress. So a lot of people ask themselves, how could philosophy be more like science? And let me tell you, that question doesn't go away. It keeps going on, and it is still going great guns now at the beginning of the 21st century. But this is really starting to get some traction because philosophy or science itself just started getting traction at this period of time. Now, one of the outstanding questions that philosophy was dealing with at the time was, how can we know the truth? Well, we talked about how do we know the truth of the axioms of geometry and stuff, but also how do we know the truth of the principles on which, say, even science relies on? So, for example, way back when, in our third lecture, I talked about Thales' conclusion that everything was made of the same substance. And the argument went something like this. Look at a cow. You see a cow eating grass and the cow's giving out milk. Now, nothing ever just vanishes into thin air or appears spontaneously out of thin air. So that milk, the stuff the milk was made of, must have come from somewhere. And watching the cow, we conclude it must have come from the grass. So therefore, the grass and the milk, despite the fact that they look, behave, feel, smell real different, must be made ultimately of the same substance, the same stuff. Now, what about that one step in the argument? Nothing ever vanishes into thin air, or nothing ever spontaneously comes out of thin air. How do we know that? Is that a legitimate step? Do we need to justify that? Remember, this argument was made back at a time when mathematical proof was essentially considered, as long as your steps you used in your proof were more obvious than the conclusion you were drawing, then it was considered okay. But that kind of developed, and they kept pushing it back, asking, well, how do we justify this? How do we justify this? Until we get down to the axioms. How do we justify those? And we have this question now of, well, what about this thing of things don't spontaneously appear or disappear? Now, that is like a foundational stone, a foundational assumption in all of science. Science sort of relies on it, and they make use of it at the time. How do we know that? How do we know? So that's one of, for example, of a question that philosophers were struggling with at the time. Do we know that? Can we actually doubt it? So we've talked about how do we know, the question of how do we know the truths of the axioms of geometry. Now also we have this question of, well, how do we know the truths of some of these foundational principles of science itself, like that things just don't spontaneously appear or disappear, or that, for example, each effect has some physical cause. So you see something and you don't just assume it just happened spontaneously, but that there was actually a cause of that. That is another kind of foundational assumption of the mathematics at the time. So in the context of the narrative I'm developing in this video series, we can see these as the following. In this context, we can actually see these questions as the question of how can we maintain the promises of mysticism that promises us universal and certain knowledge on things like this. The axioms of geometry are universal and certain. These principles of science, foundational principles of science, are universal and certain that were promised to us in the era of mysticism and the axial age. How can we maintain these universal certainties, but just make it more scientific, make it not founded on mysticism anymore, and mystical knowledge? How can we make this more rational? That's an ongoing question driving throughout this video series. And that is also now a question that Kant's going to approach in his critique of pure reason. All right, so Kant's work was entitled The Critique of Pure Reason, not because he had a problem with pure reason, but he thought that historically philosophers would just sort of reason willy-nilly. All bets were off. You could reason however you want. And that this was sort of the main reason why philosophy never got any traction. If you could look at pure reason and divide that into, okay, this is the legitimate stuff and this stuff isn't legitimate, that this would finally give us some traction and we would start making actual progress in philosophy, just like we make progress in science. So he's going to take a look at reason, and his critique isn't just a criticism, but rather a dividing up of it into the good parts and the bad parts. And if we follow the good parts, we'll do well. And if we rule out the bad parts, that'll be good for us as well. He said, you know, some people might object to the impingement on our freedom of inquiry and thought involved in that. But he said that this impingement of freedom is just like the impingement we have when a society makes laws. You know, the law says I can't just go over and take my neighbor's stuff. That's an impingement on my freedom. But the overall result of that is a much more societal progression. We are allowed now to feel safe in our possessions. We're allowed to feel safe in ourselves, and that definitely the benefits of these things outweigh the impingements on our freedom, that I can't just go and take whatever I want. And he saw his action as doing the same thing on the reasoning process, on our pure reason, and that if we finally get this straight, that's what's going to make philosophy more like science That's what's going to make philosophy be able to start actually progressing like science instead of just spinning its wheels for millennia. Okay, so what was the key thing? Where are we? In my notes. And as I said earlier, I am definitely not talking about all of Kant's stuff. I'm probably not even addressing the most important of Kant's stuff, just addressing the stuff that's relevant to this narrative. Okay. Before Kant, people believed we were all just passive receivers of our experiences. We pretty much saw things how they were. Descartes pointed out in his Method of Radical Doubt that some things aren't really as they appear. So for example, if you have a glass of water and you stick a spoon into it, because of the refraction, it looks like the spoon might be broken. Things aren't exactly how they appear, but within broad strokes, people believe that things were how they appear. In particular, they believe that our mind was a passive receiver and didn't actually didn't actually contribute anything to our perceptions. So the question, as it stood then, is how do we see, if you will, these fundamental principles of science? How do we see the truth of the axioms? All right. Now, in order to illustrate the point Kant is going to make, I'd like to take a look at some optical illusions I got from online. So let's first take a look at this one. Now, if you take a look here, and if you're looking at a circle, it stays still. But the circles in your peripheral vision appear to be rotating. If you move the center of your focus to another circle, that stays still, but the circles in your peripheral now are rotating as well. The thing is, nothing's moving. Nothing's rotating in this. Just as a warning, I tried to show this to my wife, and she has glasses on, which cuts down on her peripheral vision, and so this didn't work for her. So there might be some reasons, but in general, this is how it works. The thing is, our brain is wired such that sometimes our mind takes shortcuts in what we see, and it can interpret various combinations of colors and light and darkness in our peripheral vision as shortcuts. Supposedly, this somehow has served us well evolutionarily, paying off and being right more often than it is wrong, as in this optical illusion here. But what it does show us is that even if our visual image is not moving, our mind kind of contributes what we're, quote unquote, seeing there. And it is contributing actual motion to these circles. Our mind is not necessarily a passive receiver, but in fact shapes and adds on to what we're seeing for our final visual experience. That is, these circles is moving. Let's take a look at another optical illusion. All right, here we have a picture of a green peg on a checkerboard, and we have two squares labeled A and B. Question is, which one of those is lighter and which one is darker? The answer is, surprisingly, they are both the same shade of gray. We roll up a little bit, it says here, A and B are the same shade of gray. You know, even looking at it right now, I just cannot see that. I cannot see that they are the same shade of gray. A is darker than B. So in order to illustrate, I use this in my classes. And in my classes, what I do is I physically show them this. I have a sheet of paper with little rectangles, not quadrilaterals, I should say, cut out, covering the so that the A and the B show through. And when I cover up this picture so that you only see the A and B, it's obvious they are the same shape. And then I remove the sheet of paper and I put it back and I remove it and I put it back and they're like, oh my God, this is insane. The way that the author of this website here tries to illustrate it is what he does is he places two bars next to the A and B, which are themselves the same shade as A and B. And looking at it now, we can start to maybe in this see that they are the same shape. This isn't as impressive, I think, as my covering with a sheet of paper so that you're only looking at A and B. But I don't know. I don't know how I would replicate that for this video. So here, down here, we can see next to each other the original, the A and the B with the bars next to it, and that they are in fact the same shape. The thing is, we get this visual impression and our mind contributes to it, let's say. Our mind organizes and processes it. Our mind understands how shadows work and how light works. And since B is in the shadow, it must be lighter than it appears. And since A is in the light, it must be darker than it appears. And so therefore, when our mind sees this, it interprets B must be lighter and A must be darker. One that I think works better on a video here is this one down here. which of those two rectangles or which one of those two squares is lighter or darker, the top or the bottom? Well, take your finger and hold your finger so that it completely blocks out the horizon. It might even work better if you like close one eye. And if you do that, you will see the top and the bottom are in fact the same shade of gray. Remove your finger, you look at it, you put your finger back, remove it, put it back. It's amazing. The thing is, again, our mind understands how the world works. And when it sees this, it interprets the background and the foreground and the light and the darkness, the apparent lighting that we see on there to tell us that the top rectangle is darker and that the bottom rectangle is lighter. And so therefore, in these examples, we can start to see that we're not just perceiving the world as it is. Our mind actually contributes to our perception of the world. By the way, how it understands how the world works, it shows us stuff like rotating circles or darker and lighter rectangles, which are actually the same color, which aren't necessarily there. So it really does contribute to our perceptions. We are not just passive receivers. Our mind works on and modifies and digests for us to present to us what we think we're perceiving. So the question is now this. If I showed you, especially those later two, the shadow and light puzzles, and I just showed them to you, a picture of a peg and a checkerboard, and didn't make any comment on them, you probably would never even have guessed you were looking at an optical illusion. If I showed you that weird landscape with two rectangles above it, you probably would have never guessed you were looking at an optical illusion. How many things, what things in our daily lives do we think we are perceiving in the world around us, but is really just our mind's contribution to our experiences? I pointed those things out. You saw that those are actual optical illusions, but how many things in the world that are never pointed out to us are really just part of our mind shaping our experiences? For Kant, the answer was quite a bit. In fact, he said that our experiences of three-dimensional space and one-dimensional time are our mind's way of processing the information given to us and presented to us. If you think perhaps of someone in a virtual reality rig, they have the stream of information along a wire. So it's like a one-dimensional stream of information along a wire that feeds into the rig that is then reorganized and processed between the goggles you're wearing and your eyes and how your brain works to give you a three-dimensional experience. We don't know the dimensionality of the information coming into us. All we know is that our mind presents it to us in a three-dimensional manifold of space and a one-dimensional manifold of time. So, how do we know the axioms of geometry are true? They are true because they describe how our minds work and present experiences to us. And we know nothing better for Kant than we know our own minds. Our own minds are the clearest, most transparent thing to us, the most immediate knowledge to us. And we know these things because this is what our mind is contributing to our experiences. So in a way, geometry is kind of like psychology. It's describing how our mind works. And similarly, arithmetic and numbers, the theory of numbers, is about one-dimensional time. We could think of numbers as being line segment lengths, and if we arrange them all, it's going to make one line, and time proceeds one-dimensionally. And so our knowledge of arithmetic and numbers comes from our intuition of time. So Kant called this the manifold of space. The manifold of space is the thing in our head that our mind organizes all of our experiences and fits them into. The manifold of time is the thing in our head that our senses, that our mind organizes all our senses and then fits them into a sort of a linear time progression. Now, that's not to say that space and time don't really exist outside of us, just that we can't really tell. All we can tell is what we're experiencing, and what we're experiencing is all a result of our minds pre-processing the information and presenting it to us. This is how we know the truth of the axioms of geometry. This is how we know that nothing ever vanishes spontaneously or appears out of thin air, because that's how our mind doesn't process information in a way that allows us to experience that. This is how we know every effect had a cause to it, because our mind doesn't process information in a way that would allow an effect without a cause to actually happen. So it all becomes kind of psychological. The Copernican revolution, what Copernicus did was he removed the Earth from the center of the universe and made it rotate around the sun. People think of Kant's results in philosophy as a Copernican revolution in philosophy, because it kind of removes the external world from the center of the philosopher's attention and replaces it with our mind and what our experiences are. And now the external world kind of like revolves around our mind and our experiences as far as like what we can know and what and how we know it. So this might seem like arrogance, that everything really should be, it's all really just in our head, everything is all about us. But Kant saw it as really a kind of humility. When we do scientific experiments, one of the things scientists have to do is record what all of their assumptions are, but also record what the parameters of their equipment are, the limits of the equipment they're using are, so that you could tell exactly to what extent you can trust your results, or what your results are or are not telling you within the limits of the stuff you have and the assumptions you're making and all that kind of stuff. And that's kind of a humility, where you're really tracking out what you do or don't know from an experiment. And Kant saw this as a similar humility in philosophy, that we are tracking out exactly what we can and can't say, what we do or don't know, due to the restrictions of our equipment, which is our mind, which is the facility of pure reason. So that's, he saw himself as basically doing in philosophy, is tracking out what you can and can't do with pure reason, and what the limits of pure reason are, just in the way that in science, you can track out what you can and can't do with your equipment and what the limits of your equipment are. So, and now here's the important thing to our narrative. Here's what this is going to contribute to our story. This means that the development of non-Euclidean geometry is going to be more than just a mathematical innovation. It's going to be a violation of these rules that Kant laid out in order to keep us from going astray. Remember, Kant laid out these rules that he thought are going to be, if as long as we obey these rules, philosophy is going to get traction and we're going to progress. And so therefore, this is what we should do. And questioning the axioms of Euclidean geometry is going to violate that. That's going to turn it from a mathematical innovation to a really more ugly philosophical conflict. The greatest mathematician of the 1800s, possibly the greatest mathematician ever, a guy by the name of Carl Friedrich Gauss. He had a huge reputation in his lifetime. He was known as a great, and he had some non-Euclidean speculations that we might be able to reason non-Euclidean way, but he never mentioned them because he was afraid of the backlash that even he, the greatest mathematician of his time, possibly of all time, would face. So this whole impact was huge. Another impact on the developing story that we're going to face is that, as you can see, this makes mathematics seem all kind of psychological and in our head. And some people are going to rebel against that. They're going to want to talk about that. No, this isn't just psychology. This isn't just in our head. This is objective. And so they're going to start developing some understandings of mathematics that try to break out of our own head. Another is that, as you could probably see, this really throws a spanner in our attempts to understand infinity better. It seems like we cannot conceive of infinity in our head. We can't conceive of an infinite collection in our head all at once. And so therefore, it seems like that we should just, like the Greeks said, avoid it altogether. And this is going to as well stand in the way of any progress we're going to have on our understandings of infinity. Now, I was trained in analytic philosophy, and my next comment is going to come out of that background training, and it is not a universal opinion held by philosophers. So just put that out there. After Kant, philosophy became weird. So for the sake of these videos and this narrative, I'm not really going to cover the philosophy that was done directly after Kant. I'm probably not going to pick up the philosophical strands until the 20th century with the origins of analytic philosophy. But over the next several lectures, we're going to be talking about developments that were being done by mathematicians in mathematics, and not necessarily strongly influenced by the philosophy that was being done post-Kant. However, I will stick by my statement that Kant still had a large influence, and the things that these people were doing, they still consider what Kant had to say, or their detractors still consider what Kant had to say. So it was important to cover this. But after this video, we're going to go to some mathematical developments. As I've said before, we're going to look at the development of non-Euclidean geometry, the development of the limit theory of calculus, and then how that merges in the 20th century to a foundation of mathematics, at which time we will rejoin our philosophical brethren and talk about foundations of mathematics. As I said, a huge shift in the perspective of what mathematicians even thought it was they were doing, and the consequences of that for mathematicians after. Thank you very much.